Okay, guys, we're going to be continuing with solving trig equations. So we're going all the way back now to the very first worksheet I gave you guys. So if you have it, find it, because you're going to need it to be able to do the next things that we're going to do. If you don't have it, you're going to have to print out a new copy and then, get the answers from somebody, because the new stuff we're going to be doing is going to be based off the answers that we've already found. So this is, like I said, this is solving trig equations worksheet number 1. We're going to do problem number 1. We're going to talk about it a little bit more. So problem number 1, these were the two answers that you guys should have from the homework when you guys did it for the first time. I didn't show you all the work because we've already done that. You can look back at the answer key if you need to check out the actual homework again to see where we got these. But these were the two answers that we came up with. What these represent, we've never really talked about the directions up here. What I told you guys in the directions to do is solve each equation for all possible solutions and on the interval of 0 to 2 pi. The all possible solutions, that's what these are. That's what you guys have already done. These two answers right here represent all possible solutions. Be good if I can spell. Okay, so what we're going to do now is we're going to find the second part of the answer. Because it asked you to find that, great, we did that, but I also want you to find the answers on the interval of 0 to 2 pi. What's going on here, guys, is this represents an infinite amount of answers. This is saying that your answers for x are 5 pi over 24 plus pi r over 2. Remember what r stands for. R stands for rotations, which means if I put r's in there, like 1 rotation, 2 rotation, 3 rotations, I'll actually get answers for x's. This is an infinite amount. I want a finite number of answers. I want just the ones that fall between 0 and 2 pi. So that's what we're going to be doing. We're going to be taking the answers to the problems that you guys have already done, and we're going to plug rotations in. And we're going to find actual values for x, and as long as that answer falls between 0 and 2 pi, you'll keep it. If it turns out to be bigger than 2 pi, that's when you'll stop and you'll be done. All right, so let's talk about the first problem. I'm going to push this up a little bit. All right, so here's the answer we got to the first problem. That's an infinite number of answers. I'm going to put 1 or 0 rotations in. You always put 0 rotations in. So I'm going to say r equals 0. So literally no rotations. If I do that, that means plug 0 in for r. So you're going to take this equation and you're going to put a 0 in here. Now, if I put a 0 in here, it's going to cancel this. So I'm going to be left with just 5 pi over 24 plus 0, which is 5 pi over 24. Now, the question is that an answer? As long as that falls between 0 and 2 pi, then that's an answer, which it does. 5/24 is less than 2, so that's going to be an answer. Boom, you got an answer. That's the easy one. The next ones, you're going to have to actually do a little bit of arithmetic. So next one, I'm going to put 1 rotation in. So now, I'm going to put a 1 in for r. So I'm going to have 5 pi over 24. That's this right here. Plus, if I put a 1 in here for r, pi times 1 is just pi. That's just going to be pi over 2. So you're going to actually have to add those. Now, most of the time, they're not going to have a like denominator. So if they don't, you're going to have to get a like denominator here, which means I'm going to multiply this fraction by 12, because then it'll have a denominator of 24, and this will turn into 12 pi's over 24. And then now I can add them, because they're both over 24. So I'm going to zoom in on just this side, because I don't need the other equation right now. Make it easier for you guys to see. So now I have 5 pi's over 24 plus 12 more. That's going to give me 17 pi's over 24. Same question as before. Does that fall between 0 and 2 pi? If it does, you keep it. If it doesn't, then you're done with this equation altogether. In this case, it does, because 17 over 24 is less than 1, so it's definitely less than 2 pi. Boom, there's another answer. Keep going. As long as you get an answer that's less than 2 pi, you're going to just keep going until you find another answer. All right, next one, rotation, 2 rotations. So, same deal. I'm going to put a 2 in to the original equation for r. So that's going to give me, I'm still 5 pi over 24, plus, now there's going to be a 2 here. So that's going to be 2 pi's over 2. Now I could simplify that, but I don't need to because I have to get a like denominator anyway. If you just keep it over 2 every time, you know you're going to be multiplying this fraction by 12 to get a denominator of 24. So I'm going to multiply this fraction by 12. So if I multiply the top and the bottom by 12, it's going to give me 24 pi's over 24. Okay, now I can add them. So now I have 5 pi's over 24 plus 24 pi's over 24. That's 29 pi's over 24. Same question. Is that less than 2 pi? If it is, keep the answer. If it isn't, you'll cross it out and you'll be done with this equation altogether. That's like 1 and what? 1 and 5 24ths. So you're still good. Okay. Once you get 3 of these done, you can stop working hard. Because here's the thing. You can plug 3 rotations in if you want. Like if you want to put a 3 in here and keep doing the arithmetic and getting the like denominator, that's fine. But once you've looked at these 3 answers, you should notice a pattern. Look at that answer, and that answer. What happens is the numerator goes up by 12 every time. It went from 5 to 17 to 29, which is up by 12 each time, which means you can just keep continuing that pattern and you'll get the next one. Now, if there is no pattern here, that means you made a mistake. So that's a quick check to make sure you get, like, say, the first 3 right. In this case, I'm good to go because it went up by 12 each time. So now I'm going to go up 12 again from this, and that'll give me, what, 41 pi over 24? 41 pi's over 24. Does that fall in between 0 and 2 pi? Yes. So that one's still good. That's an answer. And you might want to figure out ahead of time when you're going to stop. So if you think about what number over 24 would be bigger than 2 pi, it would be 48. 48 over 24 is going to be too big. And that's what's going to happen on the next one. The next one's going to fail. So I'm going to write it anyway because I want you guys to see the one that fails. Here you go. If I add another 12 to this, that's going to be 53 pi's over 24. That's bigger than 2 pi, so that one fails, and there's your 4 answers. So this equation gives you 4 answers between 0 and 2 pi. You got 5 pi over 24, 17 pi over 24, 29 pi's over 24, and 41 pi's over 24. Now you got to do the same thing with this problem over here. Now, that seems like that might be a pain, but it's really not, because as long as these 2 equations that you have the same denominator, that's pi over 24, that's pi over 24, you can use the same exact pattern that you just used. The pattern was that the numerator goes up by 12 every time. So you don't have to go back and do all the arithmetic.